In question 1, we are asked to make A the subject of the formula P is 3A minus 9. So we need to leave A on its own. So P plus 9 is equal to 3A. I will divide throughout by 3 and we get that P plus 9 over 3 is equal to A. In question 2, Rob was asked to divide 120 in the ratio 3:5. So he did 120 divided by 3 is 40 and 120 divided by 5 is 24. And this working is obviously wrong, and we need to describe exactly what the mistake is. Well, if we need to divide 120 in the ratio of 3:5, we should first add the 3 and the 5, so 3 plus 5 is 8. So the first thing he should have considered was 120 divided by 8 is 15. And then he should have said that 3 times 15 is 45, so that's the first share, and the second share is 5 times 15, which is 75. In question 3, 200 students chose one language to study, so they had to choose between French, Spanish, or German. And of the 200 students, 90 were boys, the rest were girls, 70 chose Spanish, 60 of the 104 students that chose French were boys, and 18 girls chose German. We need to work out how many boys chose Spanish. So I will start by drawing a table here. We've got the Spanish, the French, and the German, and the split between boys and girls. We start by taking into account the fact that the total is 200, and we are told that the 90 were boys, the rest were girls. So we've got 90 boys in total and 110 girls. We are then told that 70 students chose Spanish, so the total for Spanish is 70. And then we had 104 students choosing French, 60 of which were boys. So for the French, the total is 104, the boys are 60, so the girls must be 44. And then finally, we had 18 girls choosing German, so 18 girls chose German. And now to find the girls that chose Spanish, I will simply do 44 plus 18, which is 62. I will deduct this from 110, and I get 48 girls that chose Spanish, which means that the number of boys that chose Spanish was 22 to make the total here 70. And therefore, we conclude that 22 boys chose Spanish. In 4, Karina has 4 tanks on her tractor. Each tank is a cylinder with these dimensions here. So we are filling all 4 tanks completely with a mixture of fertilizer and water. Now the ratio of fertilizer to water is 1:100 by volume. And we are told that she has 32 liters of fertilizer. We need to determine whether she has enough fertilizer for the 4 tanks. I will start by finding the total volume, and we start by noting that the radius of this cylinder is 40. We know that the volume of a cylinder is pi r squared h. So in our case, the total volume will be 4 times the volume of the cylinder. So 4 times pi times 40 squared times 160. The 160 is the height. This gives an answer of 1024000 pi cubic centimeters. I will be converting this into liters by dividing by 1,000 according to the ratio given here. So if I divide by 1,000, I get that the total volume of the 4 tanks is 1,024 pi liters. And then I will proceed in finding the fertilizer needed. So for the fertilizer needed, we will take into account the fact that the ratio of fertilizer to water is 1:100. So if I add 1 and 100, I get 101. So 1/101 will be the proportion of fertilizer out of the total volume. So I will be doing 1/101 times 1,024 pi, and this gives an answer of 31.85 liters, which is less than 32, and therefore we conclude that Karina has enough fertilizer. Remember, she had 32 liters of fertilizer. She will need 31.85 liters to completely fill the 4 tanks, so she has enough fertilizer. question 5, we've got two similar triangles and we are asked to work out the length of EF. Well, we know that in similar triangles, the ratio of the lengths of corresponding sides is always the same. So I will start by highlighting corresponding sides. The side BC corresponds to EF, BA corresponds to ED, and AC corresponds to DF. So I can simply say that 5 over 20, which is AC over DF, is equal to 4 over EF, which is BC over EF. So we can then conclude that EF will be 20 times 4 over 5, and this gives an answer of 16 centimeters. In part B, we need to work out the length of AB. AB is here. So this time I will say that 5 over 20 is equal to AB over 22. So to find AB, I'll be doing 5 times 22 over 20, and this turns out to be 5.5 centimeters. In 6, we've got a family who is going to do a sports quiz and then a music quiz. The probability that they win the sports quiz is 0.3. For the music quiz, the corresponding probability is 0.35. We need to complete the probability tree diagram given here. So we know that for each quiz, we either win or not. So the sum of the probabilities should be 1. So if this is 0.3, then this must be 0.7. 0.35 means that 0.65 is the probability of not winning the music quiz, and 0.65 goes here as well. And we now need to work out the probability that the family will win both the sports quiz and the music quiz. So in other words, we need the win-win scenario, which is here. So to find this probability, I will simply be multiplying the two probabilities together. So 0.3 times 0.35, which turns out to be 0.105. In question 7, we are asked to convert 8,000 cubic centimeters to cubic meters. Well, if we recall, to go from meters to centimeters, we multiply by 100, and to go from centimeters to meters, we divide by 100. So if we want to go from cubic meters to cubic centimeters, we multiply by 100 cubed, and from cubic centimeters to cubic meters, we divide by 100 cubed. In our case, we've got 8,000 cubic centimeters. We will divide by 100 cubed to go to cubic meters, and we get an answer of 0.008 cubic meters. In B, we are asked to change a speed of 180 kilometers per hour to meters per second. So this means that we start with 180 kilometers in 1 hour, which means we've got 180,000 meters in 3,600 seconds. So I change the kilometers into meters by multiplying by 1,000, and the hours into seconds by multiplying by 60, and then again 60 to go from hours to minutes and from minutes to seconds. And we're now wondering on how many meters will we cover in 1 second. So to find x, I will do 180,000 over 3,600. This gives an answer of 50, and that's meters per second. In 8, we've got 30 women and 20 men at the gym. We have the mean height of all 50 people being 167.6 centimeters. And for the men, we know that their mean height was 182 centimeters. And we need to work out the mean height of the 30 women. I like to approach these questions by drawing up a table. We've got women, men. We've got 30 women and 20 men, so 50 people in total. We have been given that the mean for men is 182 and the overall mean was 167.6. We know that if we multiply the mean by the number of individuals, we'll get the sum of the heights. So 182 times 20 will give an answer of 3,640, whereas 167.6 times 50 will give an answer of 8,380. So to do that, I will simply deduct the 3,640 from 8,380, and this gives an answer of 4,740. This is the sum of the heights of the 30 women. So we can simply say that the mean for the women will be 4,740 divided by 30, because we have 30 women, and this gives an answer of 158 centimeters. In 9a, we need to write 6.75 times 10 to the negative 4 as an ordinary number, where the negative here indicates that the decimal point should move 4 places to the left. So 1, and then 1, 2, 3, all of these will become zeros. So we end up with 0.000675. In B, we need to work out this, giving our answer in standard form. Of course, we can plug everything on the calculator. However, I would also like to show you how we can do it more analytically. So this is what we have here. 2.56 times 10 to the 6 times 4.12 times 10 to the negative 3, and all over 1.6 times 10 to the negative 2. So I will be doing numbers with numbers and powers of 10 with powers of 10. So this will give me 2.56 times 4.12 times 10 to the 6 times 10 to the negative 3, and all over 1.6 times 10 to the negative 2. Now 2.56 times 4.12 is 10.5472, and 10 to the 6 times 10 to the negative 3. We know that when we've got multiplication with a common base, we add the indices. So 6 plus negative 3 is 3, and this will be over 1.6 times 10 to the negative 2. So if I do 10.5472 divided by 1.6, I get 6.592. And if I do 10 to the 3 divided by 10 to the negative 2, I will be subtracting the indices because it's division with a common base. So 3 minus negative 2 is 5. So this will be 6.592 times 10 to the 5, which is in standard form. In question 10, we had Peter who had to subtract x squared minus 2x minus 4 from x squared plus 3x plus 5. This is the working we've been given, and we need to explain what is wrong with this working. So if we look at what they have written here, the first line is okay. The mistake is on the second line because he has minus x squared, that's correct. But then the minus 2x and the minus 4 are wrong because we've got a minus 2x. It should have been plus 2x, and then minus 4 should have been plus 4. So we need to state that the second line should have been x squared plus 3x plus 5 minus x squared plus 2x plus 4, which simplifies to 5x plus 9. In question 11, we've got x and y being integers satisfying these conditions here. We need to find all possible values of x. I will start by considering that x plus y is equal to 14, which means that y is 14 minus x. And I will substitute this into the second inequality here. So we're looking at 4 is less than 14 minus x, which is less than 10. Now we'll split this. We've got the left hand side, 4 is less than 14 minus x, so x is less than 10. And we've got 14 minus x being less than 10. So we've got that 4 is less than x. So I can put everything back together into 4 being less than x being less than 10. And I will then proceed into illustrating all I know on a number line. So we've got x. The first inequality here was telling me that x is greater than 3 but less than 8. So there it is. I'm using open circles to indicate the strict inequality. And I have also found that x is between 4 and 10, again with strict inequalities, which means that I want everything to be satisfied, and everything is satisfied between 4 and 8. So x is between 4 and 8. Remember that x is an integer and we need to find all possible values of x. Strictly greater than 4, strictly less than 8. So it could only be 5, 6, or 7. In 12, Martin used his calculator to work out the value of a number p, and he wrote down the first two digits of the answer he could see on the calculator, and he wrote down 1.2. We need to complete the error interval for p. So imagine he's seeing 1.2 and the rest has not been recorded. So it could be anything between 1.20 up to 1.299999. So essentially anything less than 1.30, and this is the error interval for p. Notice that the lower bound is included because yes, it is possible that he was seeing 1.20, but 1.30 is not included, but he could be seeing anything which is as close as possible to 1.30 from below. So anything that looks like 1.2999 cannot be ruled out. In 13, Chen had information about the time it took an operator at the call center to answer each of 90 calls. So this is the table here of cumulative frequencies. They have drawn their cumulative frequency graph shown here, and we are asked to write down two different things that are wrong on this graph. So the first thing we notice is that the points here should have been plotted against the class endpoints, and Chen here has done something different. He was plotting against the class midpoints. So the 4 here, instead of being plotted against the 10, it's plotted against the 5. So the first thing to note is that cumulative frequency should be plotted against the class endpoints. And a second point to raise will be that there is no label on the horizontal axis. We know that any graph should be clearly annotated with all the axes labeled. So the second point is that the horizontal axis has not been labeled. In 14a, we need to simplify fully 3x to the 5, y to the 6, and all raised to the power of 4. So I will start by doing 3 to the 4, which is 81. Then x to the 5 raised to the power of 4, I multiply the indices together. So that's going to be x to the 20. Then y to the 6 and all raised to the power of 4 will be y to the 24. In B, we need to expand and simplify the triple set of brackets here. So I will start by keeping the x plus 2, and I will expand the x minus 3x plus 4. So it's going to be x squared plus 4x minus 3x minus 12. I will be collecting the like terms in the second set of brackets, so x squared plus x minus 12. And I will now proceed into further expanding by doing all possible pairs. So there is a total of 6 pairs. This will give me x cubed plus x squared minus 12x plus 2x squared plus 2x minus 24. Collecting like terms together for a final time will give me x cubed plus 3x squared minus 10x minus 24. In 15, we are told that in a pet shop we've got 3 different kinds of fish, 7, 13, and 5 of each kind. And David's gonna choose one of the following combinations, either a guppy fish and an angelfish, a tetra fish and an angelfish, or a guppy, a tetra, and an angel. We need to show that there's a total of 555 different ways that this can be done. So for the guppy and an angelfish, we do 7 times 5. Remember, we multiply the number of fish we've got in each type, so it's 7 times 5. Then for the tetra or angel, it's gonna be 13 times 5, so plus 13 times 5. And then finally the guppy, tetra, and angel is gonna be 7 times 13 times 5. When we do the calculations, we get 35 plus 65 plus 455, which gives a total of 555 ways as required. In 16, we have this cyclic quadrilateral ABDE. We have the angle here being 60 degrees. We are told that the size of angle EAB to BCD is 2 to 1, and we need to work out the size of the angle BCD. it's the angle here. I will start by calling this x, and we need to show all the working. I would tend to interpret this as asking for reasons. However, if you look at the official mark scheme, no reasons were required. However, the solution I will be presenting here will indeed include the reasons just for clarity. So I will start by taking into account this piece of information here. If BCD is x, then EAB is double that, so it should be 2x, this angle here. And then I will start by noting that angle ABD here should be 120 degrees because we've got angles on a line. So ABD is equal to 120 degrees, and the reason is that angles on a line add up to 180 degrees. I will then proceed in saying that the angle here, the angle DEA should be 60 degrees. We've got opposite angles in a cyclic quadrilateral adding up to 180 degrees. So AED is 180 minus 120. This gives an answer of 60 degrees, and we said the reason is that opposite angles of a cyclic quadrilateral add up to 180 degrees. And I can now proceed into saying that I've got this triangle here, so the sum of its angles should be 180. So 60 plus 2x plus x should be 180. The reason here is that angles in a triangle add up to 180 degrees, so it's a matter of solving the equation. 60 plus 3x is 180 degrees, so 3x is 120, so x turns out to be 40. Remember, we're trying to find angle BCD, which we marked as x, and therefore I can simply conclude that BCD is 40 degrees. In 17, we've got 4 boxes, A, B, C, and D. The total weight of A and B is 3 times the total weight of C and D. The weight of A is 2/3 of the weight of B, and the weight of C is 75% of the weight of D. And we need to work out the ratio of A to B to C to D. So I need to take into consideration all of the given information. I've got 4 boxes, A, B, C, D. So I could start by calling B X, and the weight of A is 2/3 of the weight of B. So A is 2/3 X. Similarly, I will call D to be Y, and we are told that the weight of C is 75% of the weight of D. So C is 75 over 100 times Y. I can then proceed with the extra piece of information I was given at the beginning, that the total weight of A and B is 3 times the total weight of C and D. So A and B together is 2/3 X plus X, and this will be 3 times the 75 over 100 Y plus Y. And this means that we've got 5x over 3 is equal to 3 times 7y over 4. And this will help me build a relationship between x and y. So we've got that 5x over 3 is equal to 21y over 4. And this leads to 20x if I cross multiply equal to 63y. And therefore we get that x is 63y over 20. So I will go back to my original statement here and replace x with 63y over 20. This means that we have 2/3 of 63y over 20. Then we've got 63y over 20. Then it's 75 over 100 y, and then y. The first thing to do is cross out the y, which appears throughout, and we get 21 over 10. we get 63 over 20. We get 3 over 4, the simplification of 75 over 100, and we get 1. The LCM of the denominators here, the 10, the 20, and the 4, the LCM is 20. So this means that this should be multiplied by 2, this by 1, this by 5, and this by 20, which leads to 42, 63, 15, 20, and therefore to conclude, the ratio of A to B to C to D will be 42 to 63 to 15 to 20. In 18, shape A is reflected along axis 2 to give us B, and then B is reflected along axis 6 to give us C. We need to describe fully the single transformation that maps A onto C. I will try to draw something just to illustrate on what's happening. So I will start with a random shape. I will call this A. I will reflect this along the line X is 2, so it will give me something like this. I call this B, and then I draw the second mirror line, which is X is 6, and I reflect B along the line X is 6 to give me C. So let's start considering on what's happening here. I could start by calling this distance here X, so this should also be X. Now we know that the distance between the two mirror lines is 4. So if this is X, this means that this here is 4 minus X. So this here should also be 4 minus X. So I can now consider the distance here, which will be X plus 4 minus X plus 4 minus X. Notice that, interestingly enough, the x's will cancel out and I'm left with 8. So irrespective of the distance I was to the left of the mirror line originally, the distance between the vertex here and its corresponding image here will always be 8. I notice that this looks like a translation. The orientation has not changed. We're not looking at an enlargement. We're not looking at a rotation. So it's a translation by the vector 8, 0. In 19, we've got a box that contains blue, red, and green counters only. The probability of taking a counter at random, and this being blue, is 0.4. And we are also told that the ratio of red to green is 7 to 8. Now, Samina will take at random a counter. She records the color, she puts it back, and she will repeat this process 50 times. We need to work out an estimate for the number of times she takes a green counter. So let me start by just stating blue, red, green, the three possibilities. We are told that the probability of a blue counter is 0.4, which means the probability of red or green should be 0.6. Remember, the three numbers should be adding up to 1. In addition, we have that red to green is 7 to 8. So if I split the 0.6 in the ratio of 7 to 8, I will simply consider that 7 plus 8 is 15. So the probability of a green counter being drawn will be 8 over the 15 times the 0.6. So probability of picking a green counter is 8 over 15 times the 0.6. This turns out to be 0.32. And now, bearing in mind that this process is repeated 50 times, to find the expected number of times of getting a green counter, I'll be doing 0.32 times 50, which turns out to be 16 times that we expect to get a green counter. In question 20, we're given triangle ADE such that AE and DE are equal in length, so we're looking at an isosceles triangle. We are also told that the ratio of AB to BC to CD is 1 to 2 to 1. So this is 1, this is 2, and this is 1. And we need to construct a proof showing that triangle ACE is congruent to triangle DBE. So I will start by copying this diagram here and actually highlighting the two triangles that I need to prove that they are congruent. So the first one is here, it's triangle ACE, and then the second one is over here, it's triangle BDE. So we start by noting that the length AB plus the length BC is equal to the length of BC plus CD. In other words, this part and this part is equal to this part and this part, and therefore this means that AC is equal to DB, so the two lengths are equal. We were also given that AE is equal to DE, and therefore we can say that the angle BAE is equal to the angle CDE, and the reason is that we've got angles at the base of an isosceles triangle. Remember that triangle ADE was isosceles, so the angle here and the angle here were of the same size, and therefore the angle BAE, which is here, and the angle CDE, which is over here, are equal in size. Now, since we are constructing a proof, we need to provide reasons to explain any conclusions that we reach. So we need to state that angles at the base of an isosceles triangle are equal, and therefore, since we have shown that we've got the length AE and the length DE equal, and also the length AC and the length BD equal, with the angle in between being of the same size, we conclude that triangle ACE and triangle DBE are congruent. We need to state here SAS, which means side, angle, side. In 22, we've got the curve with equation y is 4x squared minus 56x. It has one turning point, and by completing the square, we need to show that the coordinates of this turning point are 7, minus 196. We must show all working. So we know that this is a parabola, it's a smiley face, it has one turning point, it's a minimum point. However, we can only use completing the square. We've been specified the method to be used. Otherwise, I could have used, for example, the symmetry of the parabola or differentiation. However, now I'm restricted to just using completing the square. So we start with y is 4x squared minus 56x. I will factor out the 4, leaving me with x squared minus 14x in the brackets, and now I will complete the square on x squared minus 14x. So it's 4 brackets x minus 7 squared. Remember, it's always half the coefficient of x, so half of negative 14 is negative 7, and then minus 7 squared, which leads to 4 brackets x minus 7 squared minus 49, which leads to 4 brackets x minus 7 squared minus 196. So what we have achieved here is that we have written y, the expression for y is 4 times something squared minus 196. We know that anything squared has to be greater than or equal to 0. So overall, this will always be greater than or equal to minus 196. So the minimum point has a y-coordinate of minus 196, and this will be attained when x is 7, when this bracket drops dead. So when x is 7, we will have the turning point, and therefore we conclude that turning point has coordinates 7 minus 196 as required. In 22, we've got this expression here. It's a triple fraction, and we need to write it as a single fraction in the given form. So we start with 2x plus 3 over x minus 5 plus x minus 4 over x plus 5 minus 3. I will actually write 3 as 3 over 1, and therefore we will be looking for the LCM of the three denominators. These will obviously be x minus 5, x plus 5. So this will be the common denominator. And we notice that the first bracket needs to be multiplied by x plus 5. The the second by x minus 5, and the third by x minus 5, x plus 5. So in the numerator, we will be having 2x plus 3 times x plus 5, and then it's gonna be plus x minus 4 times x minus 5, and then minus 3 times x minus 5 times x plus 5. So we will expand here. We are getting 2x squared plus 10x plus 3x plus 15 plus x squared minus 5x minus 4x plus 20. And then we've got minus 3 brackets x squared plus 5x minus 5x minus 25. Do not forget the denominator. I will expand this to give me x squared plus 5x minus 5x minus 25. I notice that the 5x with the minus 5x will cancel out, and similarly in the denominator here. So we've got here 2x squared plus 13x plus 15 plus x squared minus 9x plus 20 minus 3x squared plus 75, and all of it over the denominator of x squared minus 25. Now it's a good sign we have matched the denominator shown in the form of the answer we need to arrive at. Now we need to simplify the numerator. We've got 2x squared plus x squared minus 3x squared. They vanish. And then if I add up the x terms, it's going to be 13 minus 9. So it's 4x. And with the constant, we've got 15 plus 20 plus 75, which is 110. So that leads to 4x plus 110, and all of it over x squared minus 25. We therefore conclude that a must be 4 and b must be 110. In 23, we're given the graph of f of x here, and we are asked to sketch the graph of f of x plus 2. Well, f of x plus 2 simply means that we need to deduct 2 from x. Remember that when we've got the transformation applying in the bracket with x, it goes along the direction of x, contrary to what you would expect it to be going to. So I'm tempted in adding 2 to x, and I'm actually deducting 2. So this is essentially a translation of 2 to the left, and therefore we will be looking at something like this on the graph, and this will be f of x plus 2. We are then told that graph A has been reflected to give us graph B shown here. The graph of A is y is g of x, so I will highlight A. So we can see that we are looking at a reflection along the x-axis. This essentially means that all the values of y have changed sign, so anything that was positive became negative, anything that was negative became positive. So the equation of graph B will simply be y is equal to minus g of x. In 24, we're given C, D, E, F. Here it's a quadrilateral. We are told that there's a point P such that CEP is a straight line and CE is equal to EP. So it makes sense to draw a straight line CEP such that the distance CE is equal to the distance EP. And we need to use a vector method to show that CF here is parallel to DP. So I will join D with P together. So the idea is to find the vector CF, the vector DP, and if I manage to show that one is a multiple of the other, then I will be concluding that the two lines are parallel. That's what I'm trying to do here. So let's see. To go from C to F, I can go from C to D, then from D to E, and then from E to F. So it's going to be CD plus DE plus EF, and this will be 2A minus B. Well, the negative sign is indicating that I'm moving in the opposite direction, and then it's going to be minus A. So this simplifies to A minus B. And then for DP, to go from D to P, One route will be to go from D to C and then from C to P. So to do this, so it's gonna be DC plus CP. Now to go from D to C, it's minus 2A. And to go from C to P, I will be using the fact that the distance CE and the distance EP are the same. So to go from C to P, it's the same as going 2 times from C to E. So it's going to be plus 2 times CE. So it's going to be minus 2A plus 2 times, well, to go from C to E, I can go from C to A and then from D to E. So that's going to be CD plus DE. So this is going to be minus 2A plus 2 times 2A minus B, which leads to minus 2A plus 4A minus 2B, which simplifies to 2A minus 2B. I notice there's a common factor of 2, so this will be 2 times A minus B, which is equal to 2 times CF. So we have just seen that DP is 2 times CF. This means that CF is parallel to DP, and that's exactly what I had to show. In 25, we've got a pyramid P formed by two different parts. They are made from different materials. We have the mass of the top part and the bottom part. We've got the density of the top part and the average density overall for the whole pyramid. And we need to calculate the volume of the top part of P as a percentage of the total volume of P. So I will start by reminding ourselves that density is mass over volume, and this can be rearranged to give us that volume is mass over density. I like to approach these questions by drawing a table just to summarize everything. So we've got mass, volume, density, it's the top part, the bottom part, the total. So the mass of the top part is 92.8 grams. The mass of the bottom part is 972.8 grams. We've got the density of the top part being 2.9 grams per cubic centimeter. And we've got the average density for the total, which is 4.7 grams per cubic centimeter. I can now proceed, first of all, by finding the total mass. I'm adding up the 92.8 and the 972.8. So 92.8 plus 972.8 gives an answer of 1065.6 grams. And now, because I've got the mass and the density, if I do mass over density, I'll be finding the volume. So for the total, I will do 1065.6 divided by 4.7, and this gives an answer of 226.723 cubic centimeters. That is the total volume of the pyramid. Now for the top part, we've got the mass and the density. So if I do mass over density, I'll be finding the volume. So 92.8 divided by 2.9 is equal to 32 cubic centimeters. Remember, we've been told to calculate the volume of the top as a percentage of the total volume. So we know that the volume of the top is 32 cubic centimeters. The total volume is 226.723 . And to turn that into a percentage, I'll multiply by 100. This gives an answer of 14.1%. In 26, we've got a regular heptagon. Now the word regular means that all sides are of the same length. So all of these have the same length. We are being given that the area of triangle ABG here is 30 squared centimeters, and we need to find the length of GB. I will start by labeling the angle GAB as theta, and we know that AG and AB are equal in length. I could call those X, and therefore I could start by saying that the area of the triangle ABG is simply a half AB sine theta, so a half times x times x times sine of theta. I will now use the fact that we are looking at a regular heptagon. We know that the sum of the interior angles in a heptagon is 7 minus 2 times 180, because it's always the number of sides. Take away 2 and multiply this by 180. And then if I divide by 7, I will be finding the size of each interior angle, because all interior angles are of the same size. This gives an answer of 900/7 degrees. I'm not going to bother putting it on the calculator. I'm going to use the exact value here. And therefore, for the area of the triangle, which was 30, this will be a half x squared times sine of 900/7. Remember, we're trying to find x to get us started. So I will cross multiply with the 2 to get 60 is x squared sine of 900/7. And therefore 60 over sine of 900/7 will be x squared. And therefore I will take the square root of the left hand side. So the square root of 60 over sine of 900/7 will be giving me the value for x. I'm not going to use a calculator to evaluate this numerically. Instead, I will proceed now. I will be using the cosine rule to find the length of GB. So GB squared will be x squared plus x squared minus 2 times x times x times the cosine of theta. So let me write this down. We've got the cosine rule now. We know that GB squared will be x squared plus x squared minus 2 times x times the cosine of the angle, which is 900/7. So this is 2x squared minus 2x squared cos of 900/7. Well, we have established that x squared is 60 over sine of 900/7. So we have 2 times 60 over sine of 900/7, and then minus 2 times 60 over sine of 900/7 times the cosine of 900/7. This gives an answer of 249.182 ... This is GB squared. So to find GB, I will take the square root of 249.182, and this gives an answer of 15.8 centimeters. Now, an alternative approach would be to drop the perpendicular from A onto GB to create a right angle triangle here, something like this. So I'm calling this distance here y, and I can use SOHCAHTOA. So once I drop the perpendicular, I bisect the angle theta, which means that this angle here is simply theta over 2. And I can now say that sine of theta over 2 is equal to y over x, which means that x sine of theta over 2 is equal to y. Now, due to symmetry, the distance GB is simply twice y, so GB is 2y, which is 2x sine of theta over 2. We have already established that x is 60 over sine of 900/7 and all square root, and sine of theta over 2 will be sine of 450/7. We plug everything on the calculator and we get once more 15.8 centimeters for the length of GB.